Mostly how CO2 is sequestered is with photosynthesis. So this is probably a process that all of us have learned during the biology class. It means that plants, to grow and to get energy, they use energy from the sun, take CO2 and release O2, so oxygen, back to the atmosphere and store the carbon part. And then later, this carbon this plant is, let's say, eaten by the bacteria, then some of this carbon is released back to the atmosphere and CO2. So it's a very natural process that happens all the time. So there are some companies, they want to achieve their climate targets. It's impossible for them or too expensive for them to reach to zero emissions. So what they do is they pay to someone else to remove CO2 on their behalf, at least until the technologies arise for them to reach zero emissions as well, or even further reduce their emissions. My father was looking for a tool to manage our farm. He didn't find anything good, so I ended up building something for him, and then other farmers wanted to start using it as well. And this is something that we called humus balance calculator. And humus is the richest part of the soil. Basically, half of this is carbon. So you can also say soil carbon calculator, which basically predicted to farmers or communicated to farmers that if they change practices one way or another way, then how this influences carbon balance in the soil.
Welcome to Mindful Businesses presented by Sarani, and I'm your host, Vidya Iyer. In our podcast, we bring to you businesses that are mindful in their practices and processes. A mindful business employs sustainable social, economic, and environmental practices. Today, we have with us Robin Salouks, co-founder and CEO of eAgronom, transforming the voluntary carbon offset market and accelerating the transition to net zero. He joins us from Tartu, Estonia. Welcome, Robin.
Glad to be here. Thanks for inviting.
According to a research paper written by Pete Smith of the University of Aberdeen in UK, he wrote that despite efforts to curb greenhouse gas emissions, they in fact increased in the 2000s, more than in the 1990s. Making the goal of reducing the global temperature by 2 degrees Celsius an uphill battle. World Bank further reported that in 2017, the greenhouse gases increased by 60% from 1990 to 2014. Carbon dioxide is one of the greenhouse gases, though naturally occurring in our atmosphere, has increased significantly. Can you explain to our listeners what exactly is the carbon cycle? Carbon dioxide is in our atmosphere, but why is it harmful right now?
Well, in general, the problem is not in carbon dioxide, it's in people's activities, right? So carbon dioxide it's a very natural thing. It has been in the air forever, and it's part of the normal operating system and how our planet is operating. But the problem is that, especially since industrialization, people started releasing a lot of CO2 and much more than it's done naturally. And this is now warming up the climate and meaning that in some places it will be impossible to grow food and to feed local people. It means sea levels are rising all around the world, and many cities will be underwater. It means that some disease like malaria and etc. will be present in places where they were not before. Many species will go extinct, and since there's just not enough food, or their home or the place where they lived is not survivable anymore for them. So the challenge is that we have influenced the natural balance a lot, and now we have to get back to the balance.
So how did nature balance it?
In the nature, how it works is that mostly how CO2 is sequestered is with photosynthesis. So this is probably a process that all of us have learned during the biology class. It means that plants, to grow and to get energy, they use energy from the sun, take CO2 and release O2, so oxygen, back to the atmosphere and store the carbon part. And then later, this plant is let's say, eaten by the bacteria, then some of this carbon is released back to the atmosphere and CO2. So it's a very natural process that happens all the time. And then people and animals are eating this food, and at the same time, if we breathe, then CO2 is released. So this is natural circle how it goes around in the environment.
Now, when we burn fossil fuel, we release the carbon that was in that fuel, right?
Yeah, exactly.
And that causes this major imbalance, which nature cannot handle.
Exactly. So fossil fuels, basically, it comes from the term fossil already. So fossil is ancient, let's say, animals or plants that are now turned into very stable format. But as people, we have mined those, let's say, and use this as a fuel.
Companies who strive to become net zero and who are unable to avoid some of the activities that will increase the carbon dioxide in the atmosphere by carbon credits. Explain how carbon credits in general work.
As discussed before, we are part of the climate crisis, and we have to really run and sprint toward net zero emissions. Otherwise, we don't achieve our climate targets, and the climate warming will go above 1.5 degrees Celsius. And that means that it may be even not possible to reverse this later. So anyways, we have to be really sprinting toward reducing our emissions, and reaching to our net zero basically means balance. Most of this result has to come from emission reduction. So this is number one thing that all companies and people have to do. Have to find ways to live our lives, do our business without emitting CO2 or any other greenhouse gases. Now the challenge is that there are no technologies that can help us. In many cases, there are no technologies that allow us to do our business with zero emissions. We can maybe lower emissions. Let's say we start driving electric cars, or we change toward regenerative electricity like solar panels or something else. But there still might be some emissions left. Now, to compensate those emissions, we have a voluntary carbon market and the opportunity to actually remove CO2 from the atmosphere. And this is how the voluntary carbon market works. So there are some companies, they want to achieve their climate targets. It's impossible for them, or too expensive for them, to reach to zero emissions. So what they do is they pay to someone else to remove CO2 on their behalf, at least until the technologies arise for them to reach zero emissions as well, or even further reduce their emissions. And we see a few movements in the market. One is that the market is moving clearly more toward high quality and certified and sequestration-based credits. So let's start from the last item, sequestration-based. So credits can be emission reduction, for example, and this is actually one of the first credits were emission reduction credits when wind farms were planted or established in some areas. That means that in this area, there is less emissions from conventional electricity production, and emissions are reduced. That's one way. But the problem with this is that companies are expected, and people are expected, to reduce their emissions anyways. So it's difficult to consider them as carbon credits to offset your emissions. The second option is emission avoidance, like forest cutting in tropical areas and etc. And we have had recent scandals with Verra and some rainforest projects as well. And the challenge over there is that it's very difficult to say whether actually this forest, when exactly was this forest expected to cut, and how much additional value carbon credits actually create. And is it true that one carbon credit in that case equals 1 ton of CO2 removed from the atmosphere? And that's why the market is switching toward removal-based credits, which means that actually removing CO2 from the atmosphere and storing it in some place. One option is soil. This is what we are working with. Very clear option is also trees. So planting additional trees to the place where trees didn't grow before. And then there are also some technologies emerging, like direct air capture to basically sequester CO2 straight from there with some really big machines. But the problem is that these are still too expensive and inefficient today. So anyways, carbon credit, voluntary carbon market basically means offsetting your emissions with carbon credits.
Yes, and so basically what he said is that aspirationally, we should try to not put out any carbon dioxide in the air, Second step, reduce it. If you can't do both of them, try to find projects which you not only get carbon credit, but you get carbon credit for reducing and capturing and sequestering carbon.
Yeah, exactly.
You are a farmer. What do you do?
Well, in general, I'm running eAgronom, this company over here, and we are working with a lot of farmers. But I am coming from the farming family. So my father has a farm and his father had a farm and etc. And the interesting thing is, since my father is organic farmer, then improving soil is super important for him.
Organic farming, people need to get certified and things like that. But in just terms of the practice, what is the difference between an organic farm and a natural farm?
In organic farming, you have to find more natural ways to fight with disease, with insects and with weed. That means that you cannot use chemicals to kill the weed or to kill the pesticides, and you also cannot use mineral fertilizers.
And in natural farming, you would probably use other techniques to improve the soil. Is that what it is? How that would be different?
I would say that protecting the soil is same for both ways. But the thing is just that organic farmers cannot use mineral fertilizers. And that means that if you don't have a good soil in organic farming, then you will certainly have very bad results. In conventional farming, if you have bad soil, then you can compensate this with mineral fertilizers, for example.
So you did not follow the footsteps of your parents or your grandparents, but what is the path that you chose? What did you go to, technical school?
Yeah, exactly. So I studied computer science. I was very involved in farming all the summers, and obviously I was working a lot with my father. But I went to study computer science because I saw that I had learned about farming anyways. So I wanted something extra. In 2016, I was already 1 year in the university. My father was looking for a tool to manage our farm. He didn't find anything good, so I ended up building something for him, and then other farmers wanted to start using it as well.
What is the solution that your tool offered, your father?
It's a farm management tool. Basically, farmers can track what crops they are growing on each field, what products they're using. They can give tasks to their tractor operators. They can plan their finances, and they can generate reports for the government. And there was one thing that already was present in this first prototype, something that no farmer asked, but it was important for our family. And this is something that we called humus balance calculator. And humus is the richest part of the soil. Basically, half of this is carbon. So you can also say soil carbon calculator, which basically predicted to farmers or communicated to farmers that if they change practices one way or another way, then how this influences carbon balance in the soil.
What would be an optimal carbon balance?
This really depends on the region, exactly the percentage of carbon that should be in the soil. But the key thing is that in most regions in the world, soil organic carbon levels are decreasing. So we have every year less soil. And that's a problem. Right now, we have to change to the trend that we have more soil and more carbon in the soil every year to get back to the baseline level. And after this, the goal is to maintain this. But that means giving more food for the soil.
In terms of what I produce, what output I want to grow on that soil, will that also change based on the carbon content, or is there an optimal carbon content which matches my crop or plants that I want to grow?
In general, what's the main thing that I guess is changing is, first of all, you can use less inputs if you have stronger soil. Even for the same crops, you can use less inputs. That means less fertilizers and also less chemicals because there are more nutrients in the soil and your plants are healthier. Secondly, and this is especially important right now since the climate is already warming, if there are very long dry periods in some regions, having more carbon in the soil is super crucial because it increases the water holding capacities. Especially in many regions in Africa, there might be some raining seasons where you get a lot of rain for a short period and then you don't get any rain for a long period. If you have more carbon, that means your soils can hold more water over there, and also means that you don't have to worry that your plants will run out of water and your yields will be better because of that. So yeah, two very big things. One is that less inputs is needed if you have better soils. And secondly, they're more resistant to the climate change.
The more humus you have, which is the dark organic material in the soil. What is it composed of? What makes it so dark? And how does it capture the carbon?
First of all, it's a bit different color in different regions. So in some places it's more like red, in some places more brown, in some places more black. That means also that the content of this like richest part of the soil is a bit different regions. But most importantly, half of this is carbon. This is what basically gives the structure to it. And then it has a lot of other nutrients in available format for the plants.
So you realized accidentally or deliberately that you have this information in the tool that you made for your family and other farmers. How did they even understand to use the tool, right? Because most of the traditional farmers are intuitive, the way they've done it, where their forefathers have done it. And how do you convince them to use technology to even understand, like, hey, listen, this is what it is? And how did you convince them to do that?
In general, we started in Europe, and in Europe, farmers need to report to the government. That was essentially one big driver of why they wanted to use some tool to simplify this reporting. But then very soon, we were always looking for ways how to get them to apply soil-friendly practices more often. That means to reduce cultivation and soil disturbance, and means to have crop coverage all year. So you wouldn't see black soil at any time. Eventually, we came up with something that we call carbon program. That means that farmers who change practices store more carbon in the soil, carbon credits out of this, and earn some extra revenue. Now, this extra revenue is not something that is like a second yield income or a big profit addition to them, but it helps to cover the cost of improving the soil. And secondly, it helps for us to pay for the services that we provide for the farmer, like giving them advice together with our partners on how to benefit from soil-friendly practices, and at the same time do good for fighting with climate change.
We have organic farming, we have natural farming, and what you are now alluding to is carbon farming.
Yeah, you can call it carbon farming, and that's not something really new, but we can call it also just soil-friendly farming. And actually, many of those practices are good for farmers anyways. Like my father was applying, had cover crops already, and many other farmers already before. The challenge is that quite often these practices, the positive income comes later. So the investment is today and positive impact comes later. And secondly, sometimes they need some extra knowledge or know-how. And this is also something that we can provide to them.
So they should have a more long-term view. So they should have the financial capital, the knowledge, and to have that long-term view. So did the governments help the farmers make this transition? Because maybe the first 2 or 3 years, their yields reduced, they had to do more work, they had to rotate crops, not use the mineral fertilizers.
Yeah, certainly governments are helping. One thing is part of one of the rules in our carbon program that the expected yield cannot be reduced because of the carbon program. So because climate change is not the only challenge we face, also the food security, especially important in some African regions where we operate, but also in Europe. We don't want one farmer to just plant trees that would sequester a lot of carbon, but then that means that in some other place, someone has to cut trees to grow more food. So that would basically just transfer emissions from one place to another place. But what governments are helping certainly, but this is not enough. So the private support is needed as well. And this is what voluntary carbon market is providing. So we have some big companies that want to offset their emissions, and they are also helping to finance this positive change that from one hand is reducing their emissions, net emissions, also fighting with the climate change, and then improving soils, which has very many positive effects. It increases biodiversity, but also increases farmers' ability to grow food in the future. Climate is warming even further.
There is all this talk about the soil capturing carbon, but I recently heard a program on NPR where a person who believed in the soil capturing the carbon, he was a farmer himself, but he said that our expectations don't really match what the reality of the carbon capture in the soil is possible. So my question to you is how much capture technically do you think the soil, or conservatively think that the soil can actually capture?
It's important comment by that farmer, because we see also in the market some programs that offer 3 times higher sequestration rates than we do. And the sequestration rates also are very different in different regions and depend on what practices farmers are ready to adopt. We see in average that we can be happy if farmers are sequestering around 1 ton per hectare additional CO2 from the atmosphere. At the same time, we see some companies talking about 3 tons per hectare. There certainly is this gap. That's why it's even more important that we focus on certifying these credits. eAgronom is working with Verra methodology VM42. It has very robust certification process and verification process. So we have to use soil model that is validated with some local data, and then we also have to do soil samplings to actually prove that during our project additional carbon was sequestered. On the positive note, we see also governments stepping in, like European Union just recently, end of last year, proposed a EU carbon removal draft, something that, or methodology and framework draft. So basically some guideline that all the carbon projects in European Union would have to follow these principles brought out over there. So this is still in the proposal phase, but eventually what we hope is that there will be some, at least European-wide and then later also global and also in other regions like North America, some clear guidance from the government, what is needed to make sure that 1 carbon credit really equals to at least 1 ton of additional CO2 removed from the atmosphere.
So the way you verify is you test the carbon in the soil. So you're doing physical tests.
Yeah, exactly. So that's one of the things that we do. And not only ourselves, but there are independent companies in any country in the world, I would say, where farming is. There is also some local companies who are really focused on soil sampling. We are their clients to measure what's the baseline soil organic carbon levels, and in every 5 years in representative fields.
One of our guests, Collective Crunch, they use AI and use LiDAR to learn more about the soil structures and use it for carbon credits and carbon capture. Do you use any such techniques?
The challenge is right now, at least in the soil, we are using some knowledge like satellites, for example, to verify if certain practice happened, like are farmers now cover cropping and are farmers or how often are they cultivating it, etc. But we haven't found technology that can measure carbon precise enough remotely. And at the same time, so we still have to do physical soil samplings, like very traditional way. But this is an area where we keep close eye to different developers and are happy to partner up with companies who will succeed in precise enough level that is okay for the certifiers.
So I'm a farmer in the US, and the farms in the US are in the thousands of acres, even a small farm. How do I use eAgronom for my farm? First, to change my farming practices, then to understand my soil structure.
We are not yet present in US, but if we would be, then we would be through local partners. Because in every country, we are present in 11 countries, 7 in Europe and 4 in Africa. In every country, we have local partners, and these are companies who are already working with farmers. So that might be your tractor reseller, company who is selling tractors to you. That might be input resellers, a company who is selling fertilizers, crop protection products, seed to you, or some other company that you're already involved with. So most likely, let's say John Deere dealer is knocking to your door and saying that, hey, last year you bought tractor from us, but this year there is another offer that we are providing to you. And then inviting farmer to the event. And in this event, for example, happened recently in Europe in cinema, where we invited farmers and we had several presenters. We had first presenter was local soil scientist speaking about the situation of soils. Then some microbiologists speaking about how improving microbiological life in your soil will actually improve also your yields. And then some farmers who already apply those practices, sharing their case studies. That will be 80% of the event. So basically 80% of the event will be that, hey, those practices are good for you anyways. And then last 20% will be that, hey, there is this eAgronom that helps you. If you join our program, then we give you advice to actually follow those new practices. And we help to cover some of the cost of changing or adopting those new practices. If farmer is interested, then we basically map the baseline.
what practices farmer is doing today, and they're suggesting some new. And if farmer likes those practices, then we calculate how many carbon credits can farmers generate and how much income can this farmer start getting from the carbon program. And if everything is fine, we sign an agreement and start working. So farmer implements practices and sends us data about what he was doing or she was doing before and what's the new practice. And we, in the end of the year, we will verify this data that the information is correct and do our calculations and send reports to the certifier. And then certifier is issuing credits, then credits get sold and farmer gets income. And the year starts again. So this is the process. Always eAgronom is over there supporting farmer with data collection and practice implementation.
So how much does it cost the farmer to adopt your solution?
We don't ask any money from farmers. We only take cut from the credits. And depending on a country, it's different, depending on the farm size as well. But we only earn if farmer is earning.
That's probably a really good way to approach the farmer, because if you went in, I know there are some solutions, sometimes they collect the data, and for the farmer to access the data, which is useful to them, if they have to pay gobs of money, they just walk away and not really adopt the solution. So what is the goal of your solution? How much carbon do you think you will capture with, of course, changed practices? How many credits do you plan to sell, say, in the next 2 years? Very short time.
Right now, we have more than 2.4 million acres, so 1 million hectares, or even I think it's 2.4 million acres on the platform, and then 160,000 hectares, so that's around 250,000 acres, I guess, have already joined the carbon program. These farmers are sequestering around 150,000 tons of CO2 annually. We are growing this number today 5 to 10 times a year. Like, for example, our growth last month was 25%. That means that very soon we want to start sequestering then eventually hundreds of millions of tons of CO2 annually.
What other benefits do the farmers get by being part of your programs? Of course, they're improving their soil, but it may take time for them to get the yield that they are used to. And is there anything that you can help them, that eAgronom does, to help them financially during this transition?
Yeah, absolutely. If you go and buy an electric car, then very often you will get better interest rates because banks want to support sustainable activities. Now we have collaboration with some banks who are giving better terms to farmers who are in our carbon program because they want to decarbonize their loan portfolios. Actually, most of the big banks have joined Net Zero Banking Alliance and have committed to reduce emissions in their portfolios. And same with food companies as well. We see that quite soon farmers will have option whether to sell their credits or to use the credits and sell their food as low emission food. And we already have collaboration also with some big landlords who are giving better rental terms to farmers who are applying sustainable practices. And mainly because they want farmers to take good care of their land, as if you would rent out the apartment, you're probably ready to give slightly better terms to someone who will fix some things and compared to someone who will destroy it.
They all seem like such great, laudable goals. Thank you so much, Robin Salouks, for coming on Mindful Businesses. It was a pleasure to learn so much from you.
Thank you. Glad to be here.
You're listening to Mindful Businesses, produced and hosted by Vidya Iyer. We would love to hear from you. Send an email to info@mindfulbusinessespodcast.com. If you learned a thing or two from this episode, share it with one friend. Click the subscribe button to be the first to learn about our latest episodes. We recorded this podcast in Buffalo, New York. Theme music was composed by Tatum Gale. Roseanne Kurian is our marketing assistant. Ketip Karat is our podcast editor. Our advisors are Jim Stone and Anupama Pasricha. This is Vidya Iyer with Mindful Businesses.